Hello class. In this video I give you an introduction to section 5.2 in your textbook on graphing polar equations. Before we graph any polar equations, I would just like to take a minute to review graphing in general, graphing in the coordinate plane, because we'll be doing something similar in graphing polar equations. So I have here the coordinate plane, also called a rectangular grid, and you know the horizontal axis is the x-axis and the vertical axis is the y-axis. And we're going to graph what's called the squaring equation, y equals x squared. And you may recall from your algebra days the graph of that is going to be a parabola. And the first step in graphing that equation, well, let's just back up for a second. The graph of an equation consists of all the ordered pairs x, y, okay, that satisfy the equation. And then typically what we do is we plot a few of the ordered pairs in the coordinate plane that satisfy the equation, and then we play connect the dots. So I'm going to create a table over here. In the first column are some values of x. In the second column are the corresponding values of y. And then in the third column are the ordered pairs that we formed with those values of x and values of y. We'll plot those ordered pairs, those points in the coordinate plane, and then play connect the dots, and that'll give us a graph of this equation. So let's just use, let's say -2, 0, and +2 as our values of x. And when I put in -2 in for x in the equation, -2 squared is 4, so I get y equals 4. And so the first point in our table that is on the graph of this equation, right, has the ordered pair -2, 4. When x is equal to 0, y is equal to 0 squared, which is 0. And so the second point in our graph has the ordered pair 0, 0. And when x is equal to 2, right, y is equal to 2 squared, which is 4. And so the third point in our graph has the ordered pair 2, 4. So to graph the squaring equation, right, we now plot these 3 points. So -2, 4, you go to x equals -2 and then up 4. So that's the point -2, 4 in the coordinate plane. 0, 0, you know, is at the origin where the x and y axis intersect. And 2, 4, point 2, 4, you go to x equals 2 and up 4 units. If we were to plot if we were to include x equals 3, right, at x equals 3, y is equal to 9. So that'd be this point up here. And at x equals -3, y is also equal to 9. So we could include that point up there, right? That's the point -3, 9. This is the point +3, 9. And now we play connect the dots. We fit a smooth curve through those points going to the right and to the left, and now we have the graph of the squaring equation, y equals x squared. Okay, so there's a little review of graphing from algebra, high school algebra, college algebra, and we're going to be doing the same thing with polar equations. All right, so to graph polar equations, we use a polar grid. This is an example of a polar grid at the bottom of your notepad, your note handout. And a polar grid consists of concentric circles. Okay, you can see the concentric circles. Starting at the center, The center of the polar grid is the location of the pole, and the polar axis goes out to the right here. And then these rays, right, correspond, the angle on these rays, right, correspond with the angle each ray makes with the polar axis. So this ray right here, labeled 105 degrees, right, it makes an angle of 105 degrees with the polar axis. Okay. Similarly, this ray down here labeled 255 degrees, it makes an angle of 255 degrees with the polar axis. Okay. Plotting points in on a polar grid, right, is kind of same idea, similar idea with plotting points in a coordinate plane. To plot a point that's, say, right here's a column of r and theta, okay, r thetas. To plot the point to 180, you go to the ray for 180 degrees, and then you go out 2 units on that ray. So you got to decide how much 1 unit is. Well, I'm going to use the distance between each concentric circle as a half unit. So starting here at the pole, right, to plot the point to 180, I'm going to go out 2 concentric circles is 1 unit, 4 concentric circles is 2 units. So this is the point 2, 180 degrees. To plot the point 3, 270 degrees, right? We go to the ray down here labeled 270 degrees, and then we go out 3 units from the pole. So that would be 6 concentric circles. So that would be 2, 3, 4, 2, 3, 4, 5, 6 concentric circles. So this is the point 2, 270 degrees, okay? So that's how you plot points on a polar grid, right? Plotting the ordered pairs r theta. Well, let's graph the polar equation r equals theta divided by 90 degrees. So my table over here, my first column, I have some values of theta, and then I have the corresponding values of r. Okay, so each value of theta in the first column is divided by 90 degrees in the second column. And these are the corresponding values of r for these values of theta. I then form the ordered pairs, right? Taking r and theta, form the ordered pairs. And now to graph this equation, we're going to plot the ordered pairs and play connect the dots, okay? Like we did up above with the squaring equation. So the first ordered pair is 0, 0. That's the pole. And the pole is at the very center of the polar grid. So this is the point 0, 0. The point 0.545 degrees, right? I forgot the degree symbol, but the second number, right, is in degrees. So I go to the ray 45 degrees, and I go out 1/2 unit. That's the first concentric circle right here. The point 190 degrees, I go to the ray labeled 90 degrees and up to 2 concentric circles. The point 1.5, 135 degrees, right? Here's the ray 135, and I go out 1, 2, 3 circles. For the point 2, 180 degrees, we plotted it right here. For the point 3, 270 degrees, I'm sorry, this is labeled, I don't know, I mislabeled it. It's not supposed to be a 6, that's supposed to be a 3 here. Here's the point, I went out 6 circles, right? Which is 3 units, because the distance between each circle is 1/2 unit. So here's the point 3, 270 degrees. And then lastly, we're going to plot 4, 360 degrees. Well, 1 full revolution, right, is 360 degrees. So this is the ray for 360 degrees. And I got to go out 4 units, which is 8 circles. 2, 3, 4, 5, 6, 7, 8. So here's the point 8, 360 degrees. And then like before, okay, like we did in graphing the squaring equation, y equals x squared up above, we play connect the dots. So start here at the pole with a smooth curve, and I fit a smooth curve to all this, the best I can do anyway. You see, that's what the graph looks like. It's actually supposed to be a spiral. Okay, starting at the pole and connecting the dots with a smooth curve, right? We graph the spiral. So stuff like spirals and what have you, right, are easy to graph in on a polar grid. They're much more difficult to graph in the coordinate plane with rectangular coordinates.